So we have a specific region now. For the region bounded by y equals x squared minus 4x plus 4, which is this parabola over here to the right, and y equal x, which is this diagonal, this straight line over here to the right. The question is, we need to set up the integrals which finds the center of mass, x bar, y bar, where x bar is given by moment y over at mass, y bar is given by moment x over mass. It's the same structure as we've had before. What we need to do is be able to take those specifics and plug them into the specifics here, and then set up the integral that finds, and then if we felt like we wanted to, we could actually evaluate the quantity of the integral here. What we need to do is, we're going to find this, we need to find the limits of integration for one thing. And so if we don't already, if it's not already obvious, we need to find this value and this value. Well, that's the points where the two graphs intersect. And so if you don't already know this, where they intersect is where the functions are equal. X squared minus 4x plus 4 is equal to simply x by itself, which gives us x squared minus 3x plus 4. You just solve this like your glory days back in basic algebra. And by solving that, we'll get x is equal to 1, or x is equal to, what's that going to be, 4. And so we have, and so we can find those pretty straightforwardly. This is 1 comma 1. This is 4 comma 4. All right, and then this function, y equal x, this function, y is equal to, all right, this x squared minus 4x plus 4. And so all we need to do is plug and chug, right? So we have x bar is given by the integral from the endpoints of the limits, the endpoints of the integral are from 1 to 4. So all of these integrals will be from 1 to 4. We need x. I need the function, I need top function minus bottom function. Top is the line, minus the bottom is the parabola, and we need to subtract the quantity. I better move my little picture here. All right, over, and then I need total mass, and the expression for the total mass is not going to change throughout the rest of the problem. It's the total mass is from 1 to 4 of top function minus bottom function. We just don't need this piece. Top function minus bottom function. And so that's the expression for x bar. And I'm going to run out of space, so I'm going to get rid of this. And now use this to find y bar, which is the integral from 1 to 4. And now I need the average of the functions times the average of the functions times the difference. So the average is the top. So we have the top function plus the bottom function over 2. So there's sum over 2 multiplied by the difference, x minus. Notice when you subtract, you have to make sure you subtract with parenthesis as always. And I left out my dx here. I ran out of space. This mass is the same, 1 to 4. 1 to 4, so this is the integral from 1 to 4. Difference, so I need top curve, which is still the same, minus bottom curve is still the parabola. And it's straightforward. Those are the two expressions we have with the limits of my not very well drawn structure here. We have set up the integrals which find the center of mass. And if you really, really wanted to badly enough, you could actually evaluate those integrals. That's simply going to be a polynomial. And this is going to be a polynomial. So that computation should be very straightforward. It's not brutally challenging. It's keeping your wits about you, keeping all this flibberty-gibbet of notation flying around all over the place, keeping that straight and in the right sequencing that is the key to all this. And so if you have your notes written straightforwardly, that should not be too challenging to set up the integrals which find the center of mass using this structure.